In this lecture, we're going to explore the fact that we can inherit base constructors and use them in our derived classes. We will be reusing the same hierarchy we have been using, so we will have the person class, and we will be inheriting from this person to create an engineer class, and that's what we're going to be using to learn about this concept here. So the person class is what we know from the previous lectures. We have a bunch of member variables here. We have the full name, the age, and the address, and we have a bunch of constructors now. We have a default constructor, a custom constructor, and a copy constructor that we set up tirelessly in the last lecture. Now, what do we mean when we say that we can inherit a constructor? Well, base constructors are not inherited by default. And what we mean by that is that by default, it is really not possible to get derived classes to use base constructors to set up things. But it is possible to tell the compiler to use the base constructor to set up our own objects. For example, we can put our statement here saying using person, : person. This is going to tell the compiler when building engineer objects, don't use your own constructor, set up a base-like constructor, which is going to only initialize the base member variables. And the compiler is going to see this statement, and it is going to generate a constructor for you that looks something like this. So it is going to be engineer, it is going to be taking in the full name, the age, and the address, and it is going to be forwarding the work to initialize your object to the person class, and this is all this constructor is going to do. Hopefully you can see that this is called inheriting a base constructor, because all this constructor is really doing is initializing the base member variables. It's not initializing any member variable that belongs to the engineer class. So the engineer part of us is going to be basically empty, containing junk data that we get by just calling the default constructor, and we will only be initializing the data belonging to the person part of us. This is really what I want you to see. Again, the syntax is what we see here. This is going to tell the compiler to generate a constructor that is only going to initialize the base member variables, but this constructor will be callable and usable from the engineer class. Okay, so this is really what we mean by inheriting constructors. One thing you should know is that the constructor is going to be inherited with whatever access specifier it had in the base class. So if our constructor was in the public scope, it's going to be inherited with public access. So we will be able to use it from the outside and build engineer objects. If it was in a protected scope, we won't be able to use it from the outside. If it was private, we won't even be able to use it from a derived class. You should really know that. So it is going to be inherited with whatever access specifier we had in our base class. Now that we know this, let's see some things you should really be careful about. The first is that copy constructors are not inheritable. If you try to do that, you're going to get a compiler error, but you won't usually notice this because the compiler is going to insert copy constructors for you anyway. This is going to become a problem if you are doing some dynamic memory allocation and you're going to get pointers copied. This is really bad. If you don't know about this, please go back to the chapter on classes and you're going to see all the story about shallow copying and deep copying. We talked about these things. Another thing you should know is that inherited constructors are really base constructors, and what we mean by this is that they will only be initializing the base member variables. Because they are base constructors, they have no knowledge of derived member variables. That's why they only initialize base member variables. Again, as we said, the constructors are inherited with whatever access specifier they had in the base class, and it is possible to set up your own constructors on top of the inherited constructors, and you can use these things. Another thing I should really tell you is that inheriting constructors is going to make your code really confusing. It is a technical possibility, but I strongly advise against using this in your code because it is just going to confuse people. People are going to see, for example, an engineer constructor, and they are going to think that that constructor is going to even initializing the engineer member variables. But it's not going to do that because it is a base constructor. It's only going to be initializing the base member variables, and that may lead to some confusion or even really bad problems in your code. So don't use this. It is just going to make things confusing. But I wanted you to be aware of this. And if you see this kind of setup in classes out there, you will know what they mean. This is just going to inherit a base constructor and use it to build objects. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is inheriting base constructors. We are going to steal code from the last lecture, and we will be using the main CPP file, the person class, and the engineer class. This is just going to be enough for our purposes here. We're going to go back in our current project, and we're going to put this in. And we will open this in Visual Studio Code by dragging and dropping here. This is going to give us our thing. And let's go to person and see that we have our constructors in. We have a default constructor, we have a custom constructor, and we have a copy constructor. One thing you should know is that copy constructors are not inherited. So you will need to set up your copy constructors explicitly if you want to use them. Note that they won't be coming from the upstream class. You should know that. Okay, so this is the message here. Now, let's look at our engineer class. The engineer class is publicly inheriting from person, and it has a bunch of its own constructors. But what we want to do is to take out all these constructors, and we're going to take them out. I think we can, we're going to take them out. Let's do that. And we're going to go in our CPP file and also take out all these constructors here. We're going to comment them out. I think we can take out all these bad code we got from previous lectures, and we're going to just comment out our constructors. We're going to close them all with a block comment. And what we are going to do in our class is say using person. We're going to say using person. This is going to inherit the constructors from person. And now that we have this in place, the compiler is really going to generate a base-like constructor in our engineer class. In other words, we're going to have a default engineer constructor, which is just going to not initialize anything. We are going to have a custom constructor, which is going to take 3 parameters, but it is going to be an engineer constructor. And let's prove this. We're going to go in our main CPP file, and we're going to take out everything we have here. And we don't have a civil engineer file, so we shouldn't really include that. And we are going to create an engineer object. We can say enc1. Using the default constructor, we can try and print that out. And you're going to see that this code seems to work in Visual Studio Code. We can try and build this. We're going to pass this through GCC, and we are going to set up a PowerShell window we can use to run and see things. And we're going to see that the default constructor for person was called to initialize this guy. And the data is really junk data we have in person. So what the compiler is really doing behind the scenes is to generate a base-like constructor at the engineer level, and it is going to call the base constructor to initialize the person part of us. So the data is just going to be junk data we have in person, and you're going to see that the contract count is going to be 0. This is just a default constructor, which is just going to grab whatever default data we have in our object. You see the contract count is 0. If we go back in person, we're going to see that the full name is none, which is what we see here. The age is 0 and the address is none. This is a default constructor. But we can even explicitly pass in the data, and that's going to also work. So we can pass in the full name to be Daniel Gray. We can pass in the age to be 23, for example, and we can pass in a junk address, let's say something like this. And you see that this is going to work even if we don't have any engineer constructor. That takes 3 parameters. Let's go back, and you're going to see that all our constructors are commented out. But this is working because we told the compiler to generate a base-like constructor for our engineer. So it is going to also have an engineer constructor that looks like this constructor here, which takes in 3 parameters. And this is really cool, and this is really crucial to understand. So again, we are going to set up a constructor for engineer. So it is going to be an engineer constructor, but it is going to be taking 3 parameters, just like the person constructor here. And this is the message I really want to convey here. So if we run this code, you're going to see that it is going to work. It is going to call our base-like constructor for engineer, and we're going to have the data forwarded in, but you're going to see that the contract count is not going to be taken into account. So it is going to still contain some default data. If we try and pass that in, we're going to see that we're going to get a compiler error because now we have no such constructor that takes 4 parameters. The only one we have is one that is generated because of this statement here. And this is going to be a base-like constructor, which is just going to take 3 parameters, just like this constructor here. And another thing I don't think I made clear enough is that this is going to bring in all the constructors you have. Notice that we just put in this statement, but it is going to grab all these constructors we have, except for the copy constructors, which are not inherited in C++. So you should really know this. If we build this code, we're going to get a compiler error because the compiler wants to know what to do with the 45 parameter that we have here. But let's build and really show you this. You need to see this compiler error with your own eyes. Let's go in. So the build is finished with errors, and we have an error saying no matching function called to this constructor, which takes 4 parameters. If we take this out, we're going to see that this is going to work. This is going to use the compiler generated constructor as a result of this statement we have in our code. Now, if we build, we're going to see that this is going to work. Okay, the build is good. We can clear and run Rooster. We're going to see that we have the full name to be Daniel Gray. We have the age to be 23. We have our address, which is really some junk data, and the contract count has no data in. It is just the default data we have in our member variable here. We have no way to initialize this from a base-like constructor. But not everything is really bad news. If you don't want to be limited by the constructors that are generated by your compiler as a result of inheriting, you can set up your own constructors. For example, we can uncomment our engineer constructor here and bring it out of our comment. We can do something like this. We can go in the implementation file and also bring this out of our comment section. And now we will be able to use this constructor, which is going to take the 4th parameter here and do something with it. Now, if we go back in main, the code with 3 parameters is going to work. It is going to use the compiler generated constructor. But if we pass the contract count to be 4, this is also going to work because it is going to be using our own constructor here. If we build the code, we're going to see that it is going to work just fine. Let's use GCC to show this. You're going to see that the build is good. We can clear and run Rooster. Now our contract count is taken into account, and this is really cool. This is really all I wanted you to see in this lecture, that you can let the compiler generate a base-like constructor using the syntax we have in our header here. This using statement can really show up anywhere, but it is going to inherit the constructor with whatever access specifier the constructor had in the base class. And you should really keep these points in mind, especially the last one, that inheriting constructors is going to make your code confusing. People are going to notice that they can call constructors that are really not going to be initializing derived member variables, and this may cause serious problems in your code. We are going to stop here in this lecture. In the next one, we're going to explore how inheritance works with destructors. So far, we have been ignoring destructors. We are going to focus on them in the next lecture. So go ahead and finish up here and meet me there.